In this video, we are going to be discussing on the reaction kinetics. Precisely, we will be treating a part of reaction kinetics. That is, deducing the rate and the order of a chemical reaction given the concentration of the reactants. Before we continue with our topic today, I want to thank those of you who have taken some time to subscribe to my channel. For those of you who haven't subscribed to my channel, please like this video, share to other learners, and most importantly, take some time and subscribe to the channel. Thank you very much for taking your time to subscribe to my channel. Let's get started. We will be starting with question number 1. We will be starting with question number 1. Here, the question reads, for the reaction A plus B to give product, if doubling the concentration of A causes the rate to rise by 4 times, and doubling the amount of B does not affect the rate, write the rate equation for the reaction. Okay, it should be noted that we know that the rate equation for this, step number 1, let's say step 1, step 1, step 1, I can say this is step number 1. Step 1, let's say the rate equation is in this form. We have the rate, which is equals to the rate constant, concentration of A times the concentration of B. That is the rate equation for this reaction. We don't yet know the order of reaction of A or the order of reaction of B. But we have been told that doubling the concentration of A causes the rate to rise by 4. Okay, let's do some raw work here. This is rate. Okay, this is concentration of A. This is A. Okay, if we double this concentration, doubling the concentration of A causes the rate, okay, let's say 2, A is 2, this is rate, doubling the concentration of A causes the rate to rise by 4 times. If the rate rises 4 times, let's say rate is 4, then rate is 4, 2 to the power what will give 4? 2 to the power 2. 2 to the power 2 will give 4. 2 to the power 2 will give 4. Therefore, the order of reaction, the order of reaction, the order of reaction, the order of reaction with respect to A is equal to 2. That is the first section. And again, we go again. And doubling the amount of B does not affect the rate. Okay, doubling the amount of B does not affect the rate. Okay, let's go again. This is rate. This is rate, which is equal to the concentration of B. If we now rate now, if we now double the amount, doubling the amount of B, if we double B, let's say 2, it doesn't affect rate. It does not affect rate. Rate still remain rate. It does not affect rate. That is, rate is just equal to 1. Just 1. Let's say 1. It does not affect rate. Therefore, what will be the order that will give us this one? The order, the power is what? It should be 2 raised to the power 0. 2 raised to the power 0 would be equal to what? Anything raised to the power 0 is 1. Therefore, rate 1, in that case, 1 is equal to 2 raised to the power 0. Therefore, we can conclude here again that, therefore, the order of reaction, with respect to B is equals to 0. The order of reaction with respect to B is 0. Therefore, our answer, our rate equation now will be what? Our rate equation now will be what? If we have rates, the rate now will be equals to, let's repeat this, K, the concentration of A, to what? To the power 2. That's the order of reaction. Now, the concentration of B to the order what? 0. Now gives us our rate equation to be, this now gives us our rate equation to be what? Our final rate equation will be what? Rate now will be what? Rate will be equals to K A that will be the answer. This is supposed to be step number, this is step number 2. Determining the order. Determining the orders. So now you will see that this will be equal, the rate now will be equals to K into the concentration of A raised to the power 2. Because anything raised to the power 0 is 1. So this would not result in this. That is the answer. Okay. We are done with question number 1. Let's go to question number 2. Question number 2. For the reaction for the reaction X plus Y, for the reaction X plus Y to give X plus Y to give the products, if the initial concentration of X, if the initial concentration of X is increased to 4 times, the initial concentration of X is increased to 4 times of its original value, the rate of reaction increases fourfold. You know what is fourfold? What would be the rate equation? What would be the rate equation? Step number one. Step number one. Step one. Step number one. In step one, we will say 4x because we said if the initial concentration of X is increased to 4 times of its original value, the rate of reaction increases fourfold. Okay. Okay. So now, so what we'll have here will be four x to the power n will be equals to what? Will be equals to 4 times. 4 times. Be equals to 4 times. It implies that, this implies that solving the maths, we will have 4x to the power n equals to 4 to the power 1. Therefore, n is equals to what? N is equals to 1. And if n is equals to 1, the order of reaction with respect to x, the order of reaction, with respect to x will be equals to what? The order of reaction with respect to x will be equals to 1. So x is 1, the order of reaction. Now, let's proceed. The rate of the reaction increases fourfold. What will be the rate equation? Now, they have not touched y. They have not touched y. So our rate equation only from this, step 2. Step 2. Our rate equation from this would be that the rate law. The rate law will be what? Our rate law will give us this. Rate will have rate the rate will be equals to what? K x, that will be it. Because this is equals to 1. What will be the rate equation? From this, we have this. Now, we don't know the order of reaction. Solving our indices, n is equals to 1. N is equals to 1. So the order of reaction with respect to x is 1. In writing our rate law will not be equals to what? It will be k into the concentration of x, because x has an order of 1. Okay, let's go to the third example. The third example, when the concentration of both x and when the concentration of both x and the y, when the concentration of both x and the y are increased to 4 times their original values, the rate of reaction becomes 16 times. The rate of reaction becomes 16 times its original value. Write the rate equation. The same thing. Here, step 1, the first step is you need to write the rate equation. The first step for this reaction is the rate equation. Step 1. Write the rate equation for the general equation here. So the rate equation will be what? Our rate equation will be, according to the rate law, rate will be equals to the constant into the concentration of x times the concentration of y. That is the rate. That is the rate law, according to the rate law. But we are told concentration of x and y are increased to 4 times. They are increased to 4 times. So rate will be what? The change in the concentration. I want to write some differential equation here, because it will show how the rate of change of x varies. The rate of change of x is related to the change in y. Let me say d x times dy. You will see that the change here is, let me say, since their concentration, remember once more, fellow learners, the square bracket symbolizes the concentration of a reactant. The square bracket symbolizes the concentration of a particular reactant. So now the concentration here has changed. It is increased to 4 times. Let's put a 4 there. The change in the concentration will be 4 times. It has increased 4 times. Now, times the change in the concentration here has been increased 4 times too. And increasing them 4 times, what happens with the rate? The rate becomes 16 times. We put 16 here. We put 16 here. Now, putting 16 there, it is 16. Putting 16 there. Since we are looking, our major thing is we want to look for the order of reaction. So, it will be 16. 16 equals to 4 times 4, 16 to the power n. Because we are looking for the order of reaction. Now, it shows that what number would, if we raise 16 to, will give us this number 2. So it is 16. Solving 16 to the power 1 will remain 16. Therefore, we can say n is equals to what? N is equals to 1. Step number 2, the order of reaction. Step number 2, the order of reaction with respect to step 2. The order with respect to A, to X and Y, X and Y is equals to what? 1. The order of reaction with respect to X and Y is 1. Therefore, rate equation, step 3. Step 3, rate equation. Our rate equation now will be rate. The rate equation will be, according to the rate law, it will be rate will be equals to rate, which is equals to the rate constant, concentration of X, raised concentration of X raised to the power 1, which is the order of reaction, remains, times concentration of Y raised to the power 1, which remains. So this will be our rate equation. This will be our rate equation for this reaction. Question number 4. Question number 4. In question number 4, we are told a reaction is first order with respect to with respect to A, and second order with respect to B. Write differential rate equation. It's very simple. First order with respect to a reaction is first order with respect to A and second order with respect to B. Write the differential rate equation. The rate equation is very simple. You don't need to be writing anything. So you just have to say rate, that is for 1. The rate will be equals to what? Will be the rate constant equals to the rate constant K into the concentration of A because they said a reaction is first order with respect to A. Because it is first order with respect to A, it is 1 raised to the power 1, which remains the same. Then second order with respect to B, it means raised to the power 2. Okay, times the concentration of B raised to the power 2, because it is second order. That is what is expected. Rate is equals to Ka into B squared. Then question about 2. How is the rate affected when the concentration of B is tripled? How is the rate affected when the concentration of B is tripled? Okay, let's solve. Let's solve it. 2. In solving 2, the first step in solving 2 is we write the rate equation only for B. How is the rate affected when the concentration of B is tripled? Only the rate equation for B. Let's say rate is equals to what? The concentration of B. Square. Okay, that is the rate with B. Only B. Now we are told how is the rate affected when the concentration of B is tripled. The next thing is, if the concentration of B is tripled, let's write the differential this thing. Rate would be equal to what? Change in the concentration. Let me say change in the concentration of B. Change in the concentration of B. A change in the concentration of B. Now, we have been told that the change is what? It is tripled. Now, if it is tripled, the rate, if it is tripled, the rate will be equal to what? The rate will be equal to, if it is tripled, the rate will be 3, because it is change in B, it is triple. The concentration is triple, so it will be 3 squared. It will be 3 squared. The rate will be 3 squared. Rate now will be equal to what? Rate will be equal to 3, rate now will be equal to 9. Rate now will be equal to 9. Therefore, our answer here would now be equal to how is the rate affected when the concentration of B is triple. Now we can now say, since rate is equal to 9, we now therefore can say on increasing the concentration of B 3 times, the rate increases 9 times. You can now conclude like that. On increasing the concentration of On increasing the concentration of B 3 times, the rate of reaction increases 9 times. So that is our answer. On increasing the concentration of B 3 times, the rate of reaction increases 9 times. That's just all. The third part of the question. The third part of the question is what is the third part of the question? How is the rate affected when the concentration of both A and the B is doubled? How is the rate affected when the concentration of both A and the B is doubled? Now, what we are going to do here, when the concentration of A and B and both double, what we are going to do here is this. What we are going to do here is okay. So now it's 3 here. Okay. When the concentration of both A and B are doubled, when the concentration, how is the rate affected when both the concentration of A and B are doubled? Now, the first thing is write the rate equation. First thing is rate equation. According to the rate law, the rate equation with that information we have been given will be equals to K into the concentration of A and then into the concentration of B That's the rate equation. But we have been told how is the rate affected when the concentration of both A and the B are doubled. So now the next thing is, let's see the change. Let's see the change in it. So rate would be a change in this, in A, times a change in B, all raised to the power 2. And we are told, what was the change? The concentration is doubled, both A and B. So now, our rate now will be equal to what? Our rate now will be equal to A is doubled, so we have 2 times B is doubled. We have 2, but the order of B is 2. It's a square there. Now, our rate now will be what? Our rate would be 2 square is 4. 4 times 2 is 8. Our rate will be 8. We can now conclude, therefore we can conclude that when the concentration of both A and B are doubled, doubled, the rate of a reaction increases 8 times. You can say, therefore, when the concentration of both A and B are doubled, the rate of reaction increases 8 times. That's all. The rate of reaction increases 8 times. Rate of reaction increases 8 times. That is just all. Let's go to question number 5. Question number 5. For question number 5, you should be, for question number 5, this is the last question we are solving. For the reaction for the 2NOG, that is nitrogen monoxide, or nitrogen 2 oxide plus oxygen, which is a gas, to give us 2 moles of nitrogen 4 oxide or nitrogen dioxide. For this reaction, volume is suddenly reduced to half its value. For the reaction, volume is suddenly reduced to half its value by increasing the pressure on it. If the reaction is of first order with respect to oxygen and second order with respect to nitrogen monoxide, NO, what would be the nature of the rate of reaction? Yes. Reducing the volume to half its, reducing the volume of this reaction. So the first thing is, since they are looking for the rate of reaction, the first thing is, let's write the rate of a reaction. The rate for this reaction, will be this. The rate for the reaction would be, okay, so the rate of the reaction, the rate of reaction for this reaction will be K NO we are told the order of reaction with NO is second order, so it is 2. is 2 times the concentration of oxygen. And oxygen is first order. So when we have this rate of a reaction, now we are told reducing the volume to have its original value or have its value. What should come to your brain now? Step number 2, what should come to your brain now? This is a gaseous reaction. This is a reaction involving only gases. And being a gaseous reaction, concentration and volume are very, very important. Being a gaseous reaction, concentration and volume are very, very important. Concentration and volume are very, very important. So, which expression do we have concentration and volume involved? In that case, we have concentration is, we have an expression like concentration is equals to moles all over volume. But we are told concentration equals to moles all over volume. We are told volume is halved, but volume is halved. But volume is halved. Volume is halved. But volume is halved. So what can we do? Let's proceed in our calculation. The concentration now will be equal to what? Concentration will now be equal to the number of moles divided by a half. And this divided by a half, you should know that moles divided by a half, it will give us what? Rearranging this, we will have concentration. Our concentration will be equal to what? Our concentration will be equal to 2 moles. Our concentration will be equal to 2 moles. Then step number 3 here. The concentration. Now, after having this is an expression involving concentration and volume. So concentration is equal to 2 moles. Now, the concentration of both NO and oxygen are doubled. So step number 3, let's say we double the concentration of this. Let's go back to our rate equation. Let's go back to our equation. Okay. rate. This is step 3. This is step 3. This was step 2. And this was step 1. Okay, step 3. I said from this. The concentration is equal to 2 moles. So if the concentration is equal to 2 moles, if concentration is equal to 2 moles, therefore the concentration of both NO, the concentration of both NO and NO and oxygen doubles. So let's represent this in our rate equation. Because in our rate equation we have rate equals to K NO to the power 2, to the power 2, and the oxygen. So what is changing in it? Now the rate will now be what? The rate now will double. I said if the concentration is equal to 2 moles, therefore the concentration of both these and these doubles. So our new rate now will be what? Our new rate now will be equals to 2 NO. That is 2 times NO. 2 times, I say 2 times NO. No, let me just 2 NO. Sorry. So it will be 2 NO. Let me, for easy writing, 2 NO. It will 2 NO. Raised to what? Raised to 2, which is the order of reaction. The order with respect to NO, which is 2. Then we have also increased the rate here. Let me put in it 2 so that I will better understand. Let me put a 2 here so you can better understand it. So oxygen. Raised to the power 1, which is the order of reaction. These can simply be put in this order. Rate is equals to 2 square here times 2. The result of the rate will be what? 2 square is 4. 4 times 2 is 8. So the rate will be equals to 8. So the result will be 8. So they said the question was, what would be the nature of the rate of reaction? The rate of reaction will increase 8 times. Finally, the rate of reaction will increase 8 times. This implies that the rate will increase eight times. The rate of reaction increases 8 times. So that is it. Once more, here, the first step, once more, this question. They said for the reaction, the volume is suddenly reduced to half its value by increasing the pressure on it. If the reaction is of first order with respect to oxygen and second order with respect to NO, what would be the nature of the rate of reaction? The first step, as usual, as I said, the first step, as usual, is to write the rate equation using the order of reaction with respect to NO and with respect to oxygen. We have put them there. This is the rate equation. Then the second step, they have told us volume suddenly reduced to half its value by increasing the pressure. Now, volume suddenly reduces. Now the volume has suddenly reduced to half. We need to look for a similar expression where concentration and volume are involved. Concentration and volume are involved. That is step number 2. The only expression where concentration and volume are involved is concentration is equals to moles divided by volume. Volume in dm cube. But volume is halved. The volume has been halved. We now substitute the half in the volume. The volume has been halved. So we now say concentration equals to moles divided by a half. Now our concentration, rearranging this, our concentration would be 2 moles. Now, our concentration will be 2 moles. That is 2 moles of each of the reactants. So if the concentration equals to 2 moles, then the concentration of both NO, that is sodium, nitrogen monoxide, and oxygen will be 2. That's the concentration will double. So going back to our normal rate law, we write the rate equation as just as in the first case, then substituting the value of the new concentration that we have got. Substituting the value of the new concentration. Since we say the concentration of both NO and oxygen will double, substituting it, we will say rate will be equal to 2, we say 2 moles. So 2 moles of NO all raised to the square, which is the order of reaction of NO, times the 2 moles of oxygen. And if we write it clearly out to calculate the rate, it will be 2 square times 2. The rate now will be 8. Therefore, Summarizingly, we can say this implies that the rate of reaction will increase 8 times. That is how you can solve some related questions like that on the order of reaction and the rate of reaction given the concentration. Thank you for listening. Once more, if you haven't subscribed to my channel, please like this video, share to other learners, and most importantly, take some time and subscribe to my channel so that other videos will get to you. Thank you very much.